isn't related to vocational subjects. So, a science, technology, engineering, and mathematics or STEM approach can be applied to the learning environment to help overcome some of the problems as I mentioned before and improve students' critical thinking skills, as the previous STEM research pointed out that STEM provide active and meaningful learning, and by applying STEM, students can develop their higher order thinking skills, problem solving, collaborative skills, dialogue, and creativity. Science learning through a STEM approach can be combined with a project-based learning, which emphasizes contextual learning through complex activities. Students are challenged to explore and plan learning activities and carry out collaborative projects that culminate in students producing a product or making a presentations. So, this research project emphasized the integration of STEM and project-based learning as a means to develop students' critical thinking skills in a chemistry class. The next chapter is research method. The purpose of this study was to develop students' critical thinking skills through the integration of STEM and project-based learning with grade 10 students at SMK Bhaktian India as a vocational school in Banten province in electrochemistry learning. The research was conducted with the 32 students. A qualitative methodology was chosen to analyze the development of students' critical thinking skills through students' interviews, classroom observations, reflective journals, researchers' notes, and a concept test. The STEM project-based learning approach consists of 5 stages. The first stage is reflection. In this stage, students reflect on material about what will be studied. And the second stage is research, where students gather supporting information about the proposed project. And the third stage is discovery. In this stage, students look for previous findings related to the proposed project and proceed with the preparation of procedures. The next stage is application, where students experiment on making projects. And the last stage is communication. In this stage, students make project presentations, and the teacher and also students evaluate the learning that has been done. The next chapter is results and discussion. An analysis of students' critical thinking skills was undertaken using indicators developed by SCIT that measure identifying the question at issue, conceptual understanding, connecting ideas, and making assumptions and inferences. The graph of students' critical thinking skills level achievement identifies that most students' critical thinking is at a rare level with 40.63%, which means most students were able to think critically enough to formulate the main points of the problem, uncover the facts needed, and determine the concept used. Most students sufficiently identify the interconnection between concepts, were able to present assumptions and conclusions or answers supported by little evidence. The analysis of each aspect of students' critical thinking skills is as follows. The first aspect is identify question at issue. Problem identification skill were one of the high-level abilities where students demonstrated an understanding of the problem and could organize data from relevant information. The findings proved that students were motivated to explore etching and related to the concept of oxidation reduction reactions and electrolysis. This finding is in line with Yakman and Lee. They consider the STEM approach enables students to build their knowledge in solving real-life problems. Students think critically, organizing their knowledge and experience when exploring various questions related to a specific context. And the next aspect is conceptual understanding. Conceptual understanding relates to the ability to explain or interpret the meaning of a concept. In this aspect, students were expected to explain an event using existing concepts and apply the concepts to solve certain problems. The study results shows us that student 18 have been able to respond clearly using the right concept. This indicates that students' critical thinking skills have developed. This finding is in line with the result of research conducted by Rahmawati, Ridwan Hadinugrahaningsih, and Suprijanto, showing that STEAM project-based learning helps students in developing knowledge and skills by working for certain periods of time. And the third aspect is ideas connection. Ideas connection defines the relationship between concepts as the ability to connect various conceptual representations and understand the relationship between one topic with another. The interview demonstrated that students understood that the voltaic series could be used to predict whether or not a chemical reaction would take place and then apply it to the etching project. This finding proved that the application of STEM project can be one of the solutions to the problem of learning chemistry, which generally only addresses abstract theories and shows a lack of relevance. The next aspect is assumptions. Assumptions are estimates that are logical and can be justified by facts or information. Based on the findings, students 28 and 18 could explain the assumptions that were made relating to the use of pure copper as an electrode to coat the bracelet, which required the metal, that is the pure copper, as an anode to oxidize because the copper ions would move and stick to the bracelet. This finding proved that STEM project-based learning helps students develop critical thinking skills because students learn to think fluently by exploring problem solutions from different perspectives. And the last aspect is inferences. Inferences are defined as activities of human mind based on knowledge they have that enables them to describe and understand various stages of a problem and arrive at a new formula or conclusion. The finding proved that student 31 was able to deduce the cause of corrosion on motor components and provide solutions related to the preventions of corrosion on these motor components. So, this study proved that STEM project-based learning helps students to formulate several possible solutions to the problem as an important aspect of critical thinking. The last chapter is conclusion. There are a few points we can conclude from this study. The first one, the positive impact of STEM PGBL in chemistry learning that students can identify an issue, demonstrate conceptual understanding, connect ideas, and make assumptions and inferences. The second one, 40.63% of students reach a rare level of accomplishment, which means most students were able to think critically enough to identify the main points of the problem, uncover the necessary facts, determine the key concepts, and understand the interrelationship between them, make assumptions and draw conclusions, or provide answers supported by some evidence. And the third one, STEM PGBL provides a meaningful learning because students not only learn the lesson concepts, but they can apply their understanding to daily life through STEM project. And the last, the challenges faced by the researchers in this study, there are time management that must be adjusted for the number of hours of study necessary, students' involvement, and the number of projects that are possible using an integrated STEM approach of PGBL. So, that brings us to the end. I'd like to thank you for your time and attention. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you for the presentation, Alin. So it's 1:14, so 1 minute left for the presentation, but there is 5 minutes for discussion. If you have any questions, Alin is available in this room. Anyone? Anyone has a question? You can put even in the chat room for the next station as well. Anyone? So it's about, actually it is our project as well, Alin and with myself regarding the STEM project. The challenge in Indonesia is you implemented the STEM project, but it is in the chemistry classroom because we don't have any STEM classroom, for example, or science in the high school. So we have chemistry, physics, biology in the different kind of subjects. So the challenge is creating the STEM learning, but it is based on the STEM project-based learning. So we need to take the certain topics to be related to the STEM project itself. So that's we have different kind of impact on the STEM project. One of the impact is the critical thinking that we presented in this conference. Any questions? Bill, Ellie, Witri. So I have all the participants. Ada Bu Nunu. Dian, Bu Dewi, Bu Halimatul, Elda, Pak Habidin, Ridwan, Risma, Puri, Rifai, Indah. Any questions for Alin?
Silence.
Silent. Hopefully you are available in the room. So it's the challenge of Bill. Is the challenge of the conference in online, Bill. We cannot see the
expression.
The expression. Okay, so we can move to the next presenter, I think, and then if you have any more question, you can put on the chat room, and then we can discuss it later, even though the presenters already present their presentation. Okay, the next presenter is Pak Habidin. Pak Habidin, are you available to present? Okay, good.
Yes,
Pak Habidin, can you hear me? Okay, good.
Yes, that's very clear. Yeah.
Wahyu, please proceed to the second video presentation. So I would like to let you know that we will choose the best presenter through the assessment of the videos and also the response to the question if there is a question. Otherwise, we just assess through the video. So please do the participation throughout the discussion. Thank you. Silakan, Pak Abidin. Wahyu.
Assalamualaikum warahmatullahi wabarakatuh. First of all, I would like to introduce myself. My name is Habidin. I'm a lecturer from Department of Chemistry, Universitas Negeri Malang, East Java. In this opportunity, I would like to explain my paper entitled "Do Students Aware of Their Scientific Conceptions?" What is the background of this study? Plenty of study regarding students and scientific understandings have been found in many publication area. In many journals, we can find some publication regarding students and scientific understanding, as well as how to overcome this unscientific understanding and how to design a proper teaching and learning in order to address this unscientific understandings. For sure, knowledge of student and scientific understandings is very meaningful and important for chemistry or science educators. And also, actually, another factor that's also important to be acknowledged. Unfortunately, the attention in this aspect not as much as the attention for students and scientific understanding. What is that? Yeah, it is a student scientific understanding. Let's go back to the definition of student and scientific understanding first. Student and scientific understandings, or in more popular, people call it misconception, or erroneous ideas, or alternative conceptions. But in this matter, I prefer to use the terminology of scientific understanding because it really reflects the nature of misunderstanding. So unscientific understanding is a conception held by students which is unfit with the one or the concept approved by the scientific community. So scientific understanding is the opposite definition of unscientific understanding, meaning a concept held by student or a conception held by student which is approved by the scientific community. So the problem is, do students aware of their scientific understanding or their scientific conception? Because we can see in some cases, in some circumstances, when we do teaching in our class, or when we do evaluation or some tests, just say, some students, they can provide a correct answer, but when we ask more, they commonly, or some, they don't really confidence regarding their correct answer. So it probably, maybe the correct answer not come from the robust scientific understanding. That's why maybe it's important to investigate deeply. Do students aware of their scientific conception? Student awareness or awareness itself is the ability to recognize what he or she or students know about his understanding. And the awareness has a strong link with confidence. Commonly, or it implies that students who confidence in providing correct answer reflect that he or she aware of his or her scientific conception. So why awareness or confidence towards student scientific conception could be meaningful? Some studies have provide quite strong evidence that awareness and confidence boost student understanding as well as student achievement. For this reason, it is necessary to investigate student scientific awareness, because it will provide another insight to the chemistry or science educator how to design or how to boost students' scientific understanding, students' awareness of their scientific understanding, or student confidence towards their scientific conception. How this study was carried out. This study involved 70 secondary school students from a public school at Malang Regency. The instrument used was a 4-tier instrument consisting 26 questions in the topic of acid base of salt solution. So what is the 4-tier instrument? Let's see the example of a question in the 4-tier instrument. So this is the question of a question in the 4-tier instrument. In the red box, we call it answer tier, consisting multiple choice question with 4 options, 1 correct option and 3 incorrect options or distractors. And then it attached with a confidence rating. So after students choose what is the correct answer from their question, they should state how confident they are to their answer, whether very unconfident or very confident. In the box below, in the box underneath, is a green box, we call it reason tier. This one, which one of the following option is the reason for your answer to the question, is the reason why student choose the answer in the answer tier. Like the answer tier, they also have to state the confidence rating of their reason. So this confidence rating will reflect how aware students are to their scientific conception. Do their correct answer really based on a robust scientific understanding? Or maybe it's just a guessing, something like that. So how we interpret the awareness of students? So the awareness of students we interpret from the CRA index. You can see from the table that CRA index 0 to 1, we categorize as guessing. And then when we translate the awareness category, it's none, meaning that they don't have any awareness regarding their scientific conception. Maybe they provide a correct answer, but they say just guessing, not on the basis of strong scientific understanding. 1 to 3, we call it weak or less aware. 3 to 4, moderate awareness. 4 to 5 is strong awareness. We also did correlation tests between difficulty level and student awareness, and also between students' confidence rating index, CRI, and the number of students' correct answer. Let's see the result. The table shows the number of students provide correct answer and the average confidence rating index for each question from 1 to 26 question to the 26. We can see that generally when the question is answered correctly by the high number of students, the average confidence rating is also high. The highest confidence rating is shown in question number 2, in which the CRI is 4.66. It's very high, and the number of students provide the correct answer is also very high, 82%. The lowest CRI1 is in question number 8 with 3.74, falling in the moderate category. And the number of students provide correct answer is also lower than other, is only about only 32%. So in general, there is a tendency that the higher number of students providing the correct answer, the higher the average of confidence rating. How about the correlation between difficulty level and confidence rating index? This figure displays that when the index of difficulty level is higher, meaning the question is easier, the CRI also high, and vice versa. The anomaly only shown in number 13. We can see number 13, the confidence rating index is one of the peak, but the difficulty level index is very low, meaning that only a small number of students can answer this question correctly. When we dig deep, why this happened, we find that number 13 is an algorithmic type of question. It implies that Indonesian students, or at least students who involved in this study, they really have a high confidence when answering algorithmic type of question, even they provide an incorrect question. But as we say, that this reflects the number of students who provide correct answer and how confident they are. So in this number 13, we can see that this small number of students, they provide correct answer in algorithmic question with very high confidence. So it's in line with some publication that many students generally more confident in answering algorithmic type of question over the conceptual type of question. So the next figure provide the correlation between students' confidence rating and students' correct answer for the number of students correct answer for each student. We can see that in each student, the higher number he provides correct answer, the higher confidence he or she is. Let's see, for those who can answer correctly 24 questions out of 26, their confidence rating is about 4.22 to 4.68. Although the highest one is shown by those who provide only 12 questions, but a tendency provide the positive correlation. And then it is proved by the statistical test. In conclusion, this study showed that students demonstrate a high confidence rating when providing correct answer that imply an awareness of their scientific conception. This result against a common belief that Indonesian students are generally less confident of their own capability. So maybe nowadays, the Indonesian students have also boost their confidence, not the same as Indonesian student usually. This study also reveals that students tend to be more aware of confidence when answering easier questions. However, we are not too ambitious to generalize this result to state that our result is transferable to the broader context. We realize that it needs a further study covering large number of participants to produce a strong and firm conclusion regarding this issue. And that's all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much. Pak Habidin is here, sorry. So any question for Pak Habidin? It's the title is about the students aware of their scientific conception. So it's about the instrument that assess students' conception. Yeah, probably we call it misconception or unscientific naive conception, alternative conception. Anyone would like to asking question for Pak Abidin? Wah, it is the silent participant.
No, may I ask a question?
Okay, please, Bu Ella.
Yes, thank you.
Pak Abidin is the lectures in Universitas Negeri Malang.
Yeah, can you hear me, Pak Habidin?
Yes, I can hear you.
Yeah, hello, Pak Habidin.
Hello.
Finally, we can see each other,
But
even though with this technology, Zoom.
well, I don't see you. Which one?
You cannot see you. Please, Wahyu, can you turn off the slide, Wahyu?
Oh yeah. Wah, you need to turn.
Yeah.
Stop share.
Stop share, please. No. Okay. Stop share. Okay. Thank you. Yeah. Can you see me now?
Yeah, it's very clear at the moment. Yeah.
Yes. Thank you. So, Pak Habidin, can you show me maybe an example of students' response on salt solutions? Maybe because I only can see the quantitative data. Maybe I want to know how students respond about the salt solution concept.
But the answer is in the form of multiple choice because we can see that 48 instruments, so they only choose whether they are very confident, they choose 5, or they are less confident, they choose 4, 3, or just guessing 1. So there is no expression that I'm too confident.
There is
because
you didn't ask student to draw something yet, right?
Yeah, no, this is just a pilot study, so not that deep research. Yeah, maybe in the future. Good to be considered to do more digging to really understand that maybe they put some confidence really based on their confidence or just to fulfill the requirement. Maybe I'm considering like using some eye tracking or something like that because I heard some presentation that they can like interpret whether people are very confident or not based on their face. So when they answer something, the camera will analyze their face and then calculate that, oh yeah, he is very confident. So maybe in the future I will use some tools to add not only the choice 1, 2, 3, or 5.
Oh yeah. So this study only focus on the confidence of students, right? Not the misconception, yeah.
Yeah, not the misconception. Actually, this one part, but for this time I only present the conception one. So when they provide correct answer, whether they are confident or maybe just guessing or something like that.
Yeah, okay. Thank you, Pak Habidin dan Bu
Yeah, very welcome.
Thank you. So, Pak Abidin, it will be the output at the end. It will be the fourth tier or the 2 tier.
Yuli, I don't know, your video is not not connected with your voice. I don't know.
Yeah.
Yeah.
Yes, this is the faultier instrument. Yeah.
The slow internet connection here.
Have you
Yeah, this,
paid? Have you paid?
it is the faultier instrument. Actually, the instrument has been developed for some time, but yeah, the final version of the instrument and then used to collect some data and then interpret the student awareness or student confidence when providing correct answer. So yeah, that's in the form of faultier instrument.
Yeah, so that's the PhD students, right?
Wow.
Yeah.
Coming soon.
Okay, thank you so much, Pak Habibin,
Yeah,
for
welcome.
answering. Very interesting. So we will go to the next presentation by Risma. Risma Wildaria Silitonga. So the title is The Effectiveness of Mobile Learning, Integrated with Ethnopedagogy on the Metacognitive Ability of the Students in North Tapanuli. So it will be very interesting to listen about different islands of Indonesia regarding the ethnopedagogy and mobile learning.
Gentlemen,
Thank
I
you.
am Risma Wildaria Silitonga, the Magister Student of Chemistry Education Program at Universitas Negeri Jakarta. Today, I would like to deliver my online presentation on the Science and Mathematics International Conference SMIC 2020. The title of my article is The Effectiveness of Mobile Learning Integrated with Ethnopedagogy on Metacognitive Ability of Students in North Tapanuli. The technology development in digital era carries along people towards the better world of development, including education. One of the sectors that felt the large impact on this transformation is the education sector. In fact, on this current case of COVID-19 pandemic, teachers and students are working together to use online learning media so that the learning process will go on well and students will be able to understand the material well. In chemistry learning, students are expected to understand chemistry concepts in order to solve problems through building their individual knowledge. Students experience difficulties with chemistry because of their inability to visualize the structure and process at the submicroscopic level and connect it with the other chemical representative data. Ethnopedagogical approach can be applied to contextual issues in every lab to create meaningful learning. Students will not only understand the chemistry concept, but also relate the issue to chemistry. Teachers should help students to construct their own meaning and knowledge through active process such as metacognition. Through ethnopedagogy integrated mobile learning, students are expected to think critically in constructing mental models of scientific phenomena. Students use their content knowledge to solve problems, especially on acid-based topics. The methodology for this research is quantitative method to check whether the use of mobile learning media integrated with ethnopedagogy has any effect on the metacognitive ability of students and students' academic achievement on the acid-based material. Students use mobile phone as a learning media for class experiment. Teacher has stimulated the student learning motivation by describing the chemistry concept as applied in cultural tradition, which makes students more interested in chemistry learning, call it ethnochemistry. Students improve the conceptual understanding and problem-solving abilities of students in chemistry classes. Focus on making students more aware of their own ideas. Students use their prior knowledge as they develop their understanding of their different chemical concepts. Hypothesis testing used SPSS 22. The Metacognitive Awareness Inventory MAI is given with t-test independent sample test towards two classes. The questionnaire form was used on the inventory test that consists of two components, which are knowledge of cognition and regulation of cognition. The acid-based chemistry learning outcomes is able to calculate it with paired sample t-test. This research was conducted in North Tapanuli, Indonesia. The implication of mobile learning in student learning has been explored, which focusing on metacognition and learning outcomes. Based on the figure of the post-test total mean scores of the experimental class is higher than the post-test total mean score of the control class. The results show that the metacognitive ability of experimental class is higher than the control class. Based on the table shows that the relation between the metacognition of acid-based chemistry learning outcomes are correlated. The results show the metacognition abilities of students has increased in chemistry learning. Mobile learning integrated with ethnopedagogy is needed to encourage students to explore daily life problems by using their chemistry knowledge. Students were able to create new ideas by using their experiences in daily life. Finally, the mobile learning integrated with ethnopedagogy has helped students to relate the chemistry concept through an application of knowledge into everyday life. Conclusion. Based on the research, it shows that mobile learning integrated with ethnopedagogy is able to improve the ability of students' metacognitive and correlates with student learning outcomes on acid-based topic. This media contain lesson summaries, videos, quiz, and solution. So, mobile learning media integrated with ethnopedagogy are effective and flexible to be used learning media and suitable with student needs. Thank you.
Thank you very much, Bu Risma. So, anyone asking question? So Bu Risma is not yet the COVID-19. I mean, you still do it offline?
Yes. Yes, ma'am.
So it still do it on offline, not online? So you are in Tapanuli right now?
No. I'm here. But for this research, I do on
offline.
No. Yes, it's offline. I do offline since January.
January, okay.
Yes.
Any question for Bu Risma? So Bu Risma is integrated the mobile learning with the ethnopedagogy. So she developed the mobile learning and to integrate the issue of the cultures in chemistry learning. Anyone? Anyone would like to asking question for Bu Risma? Rifai, Alin, Witri, Pahabidin, Bill.
Okay. Mine maybe one question only.
Okay. Yes, please.
Okay. Bu Risma, sorry, I thought that was the major of Surabaya. And the same name, right? Yeah. Okay. One question only. What is the most important aspect from Tapanuli culture that relevant to be integrated in chemistry learning regarding your study?
Okay. North Tapanuli have many concept acid-based learning, such as for food tradisional, pertanian, and can I mix within bahasa?
Yeah, sure.
Okay.
I will translate it to Bill. So just speak in bahasa.
Oh ya. Jadi Tapanuli itu mempunyai budaya yang sudah turun-menurun itu. Mereka tidak mengetahui kalau itu sudah melakukan proses asam basa seperti untuk pertanian. Jadi mereka karena di sana kan lahan pegunungan, banyak air yang keluar dari dalam tanah itu mengeluarkan seperti air belerang. Jadi tanahnya kan mengandung asam. Jadi mereka itu untuk menanam seperti sayur ataupun jagung yang lainnya, mereka mengambil tanah dari bukit-bukit yang mengandung kapur sehingga terjadi penetralan seperti itu. Jadi itu kan konsep asam basa yang sudah dilakukan secara turun-temurun, tetapi siswa itu pada umumnya nggak tahu kalau itu ternyata asam basa seperti itu. Nah, itu adalah contoh-contoh budaya kegiatan yang sudah dilakukan secara turun-temurun, tapi bisa kita masukkan ke dalam konsep pembelajaran di kelas sehingga pembelajaran lebih menarik. Jadi siswa itu tidak hanya memahami konsep kimia aja, tetapi dia bisa menghubungkan isu apa yang ada di kejadian sehari-hari dalam kehidupannya, bisa dikaitkan ke dalam kimianya, sehingga pembelajaran itu nggak hanya paham konsep kimia, tetapi lebih bermakna untuk dipelajari, seperti itu.
Yeah, that's very interesting. Thank you for the explanation, Risma. That's quite interesting to be more contextual chemistry.
Yes, thank you, Pak
Yeah.
Abidin.
Welcome.
Thank you, Bu Risma. Pak Abidin, thank you. And then, Bu Risma, how about the mobile learning itself? It is okay, I mean, the connection in the Tapanuli for the student using the mobile learning in teaching and learning.
Does it need internet? Quota?
No. Because the mobile learning kan is offline. I give for the students use share it and Bluetooth to share our students.
So while they are using it, it will be offline.
Yes, offline.
Very much, Bu Risma, very good presentation and answering the question. And the next presenter is Bill Palmer. So Bill already joined us here. The title of Bill William Palmer. I used to call him Bill. So the complete name is the William Palmer. And the title is Henry Edward Armstrong, 1848 to 1937, and his Australian adventure. So it will be interesting to listen to Bill's presentation. Please, Wahyu.
Hello, everyone. My paper is Henry Armstrong and his Australian Adventures. Armstrong's main biographer was Vargas Eyre, who had been his former student. Eyre's account was said to be a labour of love. There are numerous biographies and biographical articles as indicated on slide 1. Armstrong's own writing is a valuable source of information. He also completed more than 300 research papers and had an extensive correspondence.
Yeah.
The main aim of this study is to relate Armstrong's life and opinions to scientific issues which are still under discussion today. Armstrong started off as a researcher in organic chemistry, but continued to widen his interests over a long lifetime, holding controversial opinions on a wide range of topics. Armstrong's biography and his family relationships on slide 2 have been greatly compressed in this presentation. Method. The methodology was initially biographical and chronological, with data triangulated wherever possible. Some issues follow. The weirdness of water was a headline in Chemistry World in April 2020, showing that there is currently no consensus on water structure. In 1906, Armstrong proposed his hydrogen theory and attacked theories of dissociation such as those of Arrhenius. Armstrong's main contribution was in making his opponents sharpen their theories. In 1888, Armstrong advanced the quinone theory to account for the color of organic compounds. Chemists found this a useful generalization. Armstrong did pioneer work on the structure of benzene and devised a successful centric formula well before the electron was discovered. Armstrong strongly opposed the ideas of ionization in solids and in solution, and did not accept radioactivity as a reality. He did not like the ideas of curly error representation in organic chemistry. His ideas on the pasteurization of milk have echoes in today's views, for example, in a recent ABC broadcast. Results. 1. Armstrong's views of the scientific education that women should receive were certainly biased against women. He favored domestic science for girls. He supervised his research well. for both male and female students. He bitterly opposed women entering learned societies and wrote a terrible obituary for Hertha Ayrton, the wife of his best friend. Armstrong had a wide variety of educational experiences that provided the basis for his strong views. He favored heuristic education, which was a child-centered method of learning through experience and experiment. His emphasis on heurism influenced the Nuffield scheme in Britain in the 1960s. In technical education, Armstrong's new course in chemistry started with the observation of familiar phenomena such as combustion. Students were always to move from the known to the unknown. Armstrong stated his dislike of the didactic teaching method as quoted on slide 4. Much of his later life, Armstrong complained about the dryness of a lot of science teaching, suggesting that the science taught should allow the students to see the meaning and purpose of the natural world. Many modern educators echo these views. Armstrong had a long and helpful relationship with Christ Hospital School. A former student commented that his teacher, using the heuristic methodology, taught science to teach us to think, to reveal to us powers that we ourselves possessed. Results 2. Armstrong's travels to Australia. Armstrong enjoyed travel. His visit to Australia was to attend the 1914 British Association meeting. The conference started just before World War I. Armstrong presented a major address on science education in Melbourne. In Sydney, Armstrong gave a public lecture to chemistry and agriculture sections. Armstrong then travelled to Brisbane, where he repeated some of his lectures. On the 3rd of September, he left Brisbane for Surabaya on board the Montoro. On arrival, Armstrong spent some time exploring this part of Indonesia before proceeding to Batavia. Armstrong's return to Ceylon and India. He returned via Ceylon and India. In this section of the study shows Armstrong's extensive knowledge of organic chemistry, agriculture, and natural products of commercial value. The topics considered are rubber, betel nut, quinine, and indigo. Armstrong visited the rubber plantations in Ceylon. In 1886, he and A.K. Miller were the first to find 1,3-butadiene in petroleum. Later, a Russian chemist polymerized butadiene to make a rubber-like substance called polybutadiene. Initially, this was of no commercial interest, but during the World Wars, the process of making rubber artificially became more important. Currently, huge amounts of butadiene are manufactured. Armstrong's interest and early research led to spectacular consequences. On his rail journey, Armstrong tried chewing betel nuts while a passenger. He would have been struck by the colour changes. He visited a factory that produced quinine at the Cinchona plantation in the Darjeeling Hills. The economic history of production of quinine is varied. Currently, there appears to be a new interest in quinine because President Donald Trump sought more sources of hydroxychloroquine, believing that this was a miracle cure for COVID-19. Armstrong's next visit was to the Agricultural Research Institute in Pusa in Bihar State. Because of his long-standing interest in dyes, colour, indigo research. Earlier, German research had led the way to indigo being produced synthetically. Armstrong retained connections with the industrial dye companies and continued to advocate support for Indian natural indigo so that it could compete with artificial indigo. Conclusion. There are very different opinions about Henry Edward Armstrong. One view was that he was cantankerous and reluctant to accept 20th century science. Another was that he was a great personality who was almost a genius. Readers will certainly form their own conclusions to Armstrong's personality, but he was certainly a great chemist, a gifted educator, and an effective communicator of science. Thank you. The end.
Thank you so much, Bill. Question for Bill is regarding the Henry Edward Armstrong. We call it Armstrong, who contribute in the organic chemistry, and also regarding the agricultures. And I just know that he is traveling to Indonesia, Bill.
Yes, he was. He enjoyed travel, and that was coming to Indonesia. He spent about 2 weeks in Surabaya. Yeah.
Oh, really? Very good.
Looking at his natural products and so on. Yes.
Okay. So I need to ask question. If we would like to use this kind of knowledge that for our students in learning chemistry, what is your suggestion that we use the story of the Armstrong to engage students in chemistry learning?
I think that Armstrong had ideas of his time that represented some of the things that are relevant to us today. And perhaps the one that would be relevant to your students might be his interest in natural products and the competition between natural products and synthetic products and the economics of that. And that's the relevance that he would have to today's students, I think. Women's students will not like him because he had a...
This woman against the bias of women.
He was, well, he was a person of his times, I think you have to say, but he was biased. But on the other hand, the women students that he looked after as a researcher, he actually evidently treated them well personally. It was just when they tried to get into learning, he didn't believe women should work. He thought that they should go back home and have children. That was his view. And it was a view of the time. So he tried to prevent them joining learned societies. And that's where most of the quarrels come from.
Oh, interesting. Probably I should teach my student teachers to understand each of the person in chemistry, Bill.
Yeah. Well, since I've retired, I'd say I was interested before, but I've now sort of an obsessive interest, becoming interested in former important chemists. Yeah.
Yeah, right. Any question for Bill, Pak Habibin, Bu Risma?
Okay. If no one has the question, may I have some?
Yeah, Bill, there is Pak Habibin would like to asking question to you.
I want also.
So who go first? Is it mine or?
Pak Habibin first.
Okay, thank you, Bu Yuli. Bill, that's a very interesting story regarding one of the person who contribute much in chemistry. I would like to ask, because in your first slide, you say that Armstrong did the pioneer work on the structure of benzene. So who did first? Is it he did before Kekule find the structure of benzene?
Kekule was ahead of him. It was happening around the same time.
Okay.
Armstrong used that idea of Kekule, is that it was a six-membered ring, and he was able to use other evidence to agree with that structure. Yeah.
Okay, I see. Yeah. Okay, may I have one more?
Yeah, sure.
Okay. He also against the meaning that disagree with the examination. Like in our country, in Indonesia, we have a big issue, big debate regarding national examination, particularly. So some people think that national examination is not important, so we have to ignore it. But some people still keep the the system in the throne. So Do you
It's
have
just what
some suggestion regarding this issue?
Yeah, it's just the main point that I'm making, that issues that were relevant 100 years ago are still coming up as relevant today. And I mean, the other point about exams is that it provides an element of fairness in one sense, that everybody from the bottom up has a chance. And some people like exams because it provides that equal basis. But then you'd argue again that it didn't provide an equal basis because some people have a better start than others. And so I think Armstrong's view was that it didn't teach chemistry. You could only learn chemistry by doing it. That was his view. And that's a heuristic method.
Okay, thank you, Bill.
Thank you very much, Ariji.
Yeah, I think you should give us the lectures sometimes, Bill, to our student regarding the history of science, because we just know the theory and then we don't know about the history of that kind of theory itself.
Thank you.
Even the person. Okay, Hima, any question? Hima, please.
Okay. Thank you for the occasion, really. It's very interesting explanation about what's that? Armstrong biography, yeah, Bill Palmer. I want to ask, actually just personal opinion, we know that Armstrong is a great scientist, great chemist. Why, what is your most what is your most point from Armstrong that you feel very interesting with him? So it will inspire you to explore his life and share with us. Thank you.
Yes, Bill, please.
Yeah, well, I'm just interested in scientists generally. I think in the last, say, 10 years, I've looked at some, probably 2 or 3 different scientists a year. And so he's just, well, he's one that's come up again. I'd written about him about 15 years ago, and I wanted to try and do something different about him this time. And I tried to concentrate on his journey from Australia through Indonesia, through Ceylon, and through India, and his interest in natural products, and those natural products that are still relevant today. So I was trying to get his relevance to today's world. I don't know if that answers your question.
Yes, I remember 2 years ago, Bill also presenting regarding the hydrogen, Bill, in SMIC 2000.
Hydrogen, what's that?
So you presented in 2018 regarding the hydrogen.
Yeah, it was looking at manuals, American manuals, and seeing what students thought at that time about hydrogen. Yeah.
Okay, thank you very much, Bill, Pak Abidin, Hima, to asking the question. And then we have the next presentation of W3. So please feel free, because the presentation will be 12 presenters. So if you would like to go to the toilet, take a drink or relaxing, please do. I don't want you get stressful about waiting for the presentation. Presentation is regarding our group research as well, regarding the developing elementary school students scientific literacy through integration of ethnopedagogy. Yes, please, Wahyu. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Wit Gesandriani from Chemistry Department, Faculty Mathematics and Science, Universitas Negeri Jakarta. I'm as one of author of UNJ team. Now I would like to deliver my presentation in Science Mathematics International Conference 2020. And the title is Developing Elementary School Students' Scientific Literacy through the Integration of Ethnopedagogy. Now let's start from the background. According to the National Education Standard Agency, or BNSP, explained, science subject in elementary school aim to have the following abilities: developing knowledge and understanding of science concepts that are useful and applicable in everyday life, increasing awareness to participate in, and maintaining and preserving the natural environment. Understanding the relationship between science, technology, and society, including in the development of social and economic aspects, is the key outcome of science learning. Science learning is expected to develop students who can respond effectively to the progress of science and technology through scientific literacy learning. Scientific literacy is distinguished by the four dimensions of content, process, context, and attitude. Program for International Student Assessment, or PISA, is a triennial survey program created by the OECD to overview and insight into the roles and trends in the achievement of knowledge and skill in the countries that are incorporated. According to the results of a PISA study of scientific literacy conducted every 2 years, the ability of Indonesian students to compete every 2 years, that Indonesia's rank of 74 out of 79 countries with a score of 379 is well below the desired level when compared to the other countries. The low level to scientific literacy means students are less responsive to the problem that exist in environment, especially those related to natural phenomena and to the unique problem that exists in local environment. Therefore, it is necessary to develop a strategy to improve scientific literacy, which utilize a learning model based on local excellence. Ethnopedagogy is an effective learning model for connecting culture and science. Ethnopedagogy is is related to the classification of societies, to culture-related physical phenomena, and to cultural system, and incorporate the values and the knowledge of the society. Science learning integrated with ethnopedagogy aims to reconstruct cultural knowledge. The research project discussed in this paper integrated Indonesian culture into science about heat. Heat is relevant to daily life as many activities involve to the use of heat. Cultural understanding has a broad meaning that is not only related to art, dance, or traditional ceremonies, but it also can interpret it as a habit. Therefore, this study seeks to link the culture of Indonesian people to the concept of heat in science education. Now let's move to the research method. The research discussion in this paper is a qualitative approach where we collected through reflective journal, interviews, and a scientific literacy test. Now, this is the 5 stage of ethnopedagogy learning. First is self-identification. Students are reflected in their culture and self-identification. Second is content integration. Students are involved in understanding culture and constructing knowledge through articles about heat utilization that are integrated with the culture of Bangka, Papua, Sumatra, and Rote. The third is collaboration. Students do the covering of JAR project in group. And the fourth is dialogue. Students presented the result of their project and discussed with others. And the fifth is reflection. Students recognize themselves and develop a cultural awareness to respect difference, especially in collaborating with others. Now, let's move to result and discussion. First, self-identification. From the interview result, It appears that students have different learning style. In the view response, it appears that to show that students know their own cultural background. And the second is content integration. Integration of ethnopedagogy in science learning could develop an understanding of heat transfer through the use of culturally explicit articles that integrate local wisdom with science education. The third is collaboration. At the collaboration stage, the activities help develop the participants' problem-solving skills by enabling them to work together on problems that are difficult to solve individually. The fourth is discussion. Students presented the result of their project and dare to speak in front of class. It can help develop student communication through speaking in the public. And the last is reflection. This stage in the process provided opportunities for students to reflect on their experience during the learning process. Now, this is the result in discussion for scientific literacy test. The research project revealed the degree to which integration of metapedagogy in science learning can develop student scientific literacy. Now, first is about content knowledge. Students could answer some question about application of heat in daily life and how to measure temperature. However, on some questions, students were confused about the definition of heat and temperature, where heat was referred to as temperature transfer. The second is scientific competence. The results of the scientific literacy competency test showed that students were not being able to explain the phenomena of people who are cold when in a low temperature environment. Students reasoned that heat transfer had occurred, but they couldn't explain how the heat moves or from where. The third is scientific context. Students are able to effectively explain the phenomena of rain and its relationship to heat. Students explain the rain occurs because of heat from the sun. It's called radiation. And the last is aspect of attitude. Students began to have an interest in science and to make decisions based on science. They were motivated to act responsibly toward natural resources and the environment. Conclusion. The integration of ethnopedagogical approach to science learning helps to develop student scientific literacy skill. By participating in this research, students gain new experience in learning science that was integrated with their culture, revealing the importance of science in daily activities. This study found that ethnopedagogy developed aspects of knowledge content, competence, and context of science and attitude. Learning through ethnopedagogy can present a meaningful learning for students because they are not only learn about concept of science, but also they learn about how they implement it in their culture. That's all my presentation. Thank you.
Thank you very much, Witri. So the research is about...
Ladies and gentlemen.
Is Fajar not yet? So Wahyu. So the research is about the ethnopedagogy. It's almost similar with Bu Risma research. It will be the next presentation as well with Hima. So the research about the ethnopedagogy regarding the integration of the culture in chemistry, ethnochemistry, ethnopedagogy, and then it is conducted in different island with us. It is in Sumatra, and then Burisma also in Sumatra, but different province. Anyone would like to asking question? Bu Halima, Elda, Indah. Anyone would like to asking question? No? Hope it's clear. Wait, any chat, please. Or anyone would like to click the attendance in this parallel session? There is in the chat box. You can click on the link and then you can put your name and fill the form regarding the attendance of this parallel session. Thank you. Okay, is Fajar, probably if there is no question, we just move. Thank you, Witri. So we just move to the next question, next presenter. It is Fajar, but it's Fajar. Fajar, are you join us? Fajar.
Yes, I'm here.
Okay,
Hello.
good. So hello, thank you. So Wahyu, could you please share the Fajar presentation and then we can join to listen the presentation. Thank you.
Thank you very much. Thank you for joining with me in this video presentation. My name is Fajar Julianur from Business University, and I'm here to represent the other authors to present our work on student cognitive level achievement in the textile chemistry lesson conducted in a blended learning environment. So before I move forward, I would like to share with you a little bit history or background of this study. So the study was coming from our concern that due to the abrupt change that we are experiencing now, which was a result of COVID-19 pandemic, the higher education institutions have decided to transfer their on-site or in classroom teaching and learning into online learning. And we thought that what change it could cause on students' learning success. We have actually conducted several literary review on this concern, and we found that the previous study dealing with this context of situation was only related to measuring the students' academic success based on their learning outcomes. Only learning outcomes, which is a merely score. But most of the study did not really investigate on the quality of the learning achievement. The quality here, that we thought of was that learning should not only give effect on student score, but there should be also change or impact on their cognitive state, right? So we were thinking to conduct this study to present an identifications of the students' cognitive level that they achieved after participating in a certain lesson that we taught during this distance learning period. And the lesson that we took was the textile chemistry. And why this becomes interesting? Textile chemistry was actually an applied science, a course which deals with not only students needs to achieve a certain score, but also needs to demonstrate a certain quality. And this quality, of course, is pretty much influenced by their complexity of thinking. And yeah, logically speaking, we can say that if a student can do a certain task, they mean that they are competent in it, in the task they are doing. And competence has pretty much great influence on their employability in the future. And that's what we want, right? We want our students, after graduating from our university, we want at least they could be they could aim for certain positions in industry that they think relevant to their skills or the competence they have, right? So that's why the study we thought was significant. And yeah, if we take a look at the previous studies have been conducted, as I have also addressed briefly previously, the previous studies on blended learning environment has seen not really taking a look at the students' cognitive level as indicator of their academic success, especially in the context of textile chemistry lesson in higher education institutions. We haven't seen many. So this study could be an open door for to invite other studies in the future to address these issues. Now, ladies and gentlemen, I would like to invite you to take a look at how we conducted this study. So as I've mentioned earlier, that this study was to measure the students' cognitive level after participating in textile chemistry course. So the method that we incorporated in this study was the one group post-test design only. The one group post-test only design, which involves the 54 undergraduate students from the Apparel Design Study Program, Universitas Negeri Jakarta. For those of you who are not really familiar with what textile chemistry is, so this course, the course was generally aimed to equip the students with knowledge and also competence to apply chemistry or chemical substances, to be exact, in dyeing and also finishing processes. And they were also invited or introduced to the fundamental principles of dyeing and finishing technology, which involves chemical reactions. All right, now as the learning platform, the online learning platforms that incorporated in the blended learning environment, we have the learning management system or LMS Moodle, and we also have YouTube, Zoom, and WhatsApp Messenger. I don't really want to go further on how those platforms were incorporated in detail, since we have a very limited time for that. But one thing that I can say to you, that the learning and teaching processes employ the 3 stages of teaching and learning process, which is ruled in the visualization-based tutoring framework proposed by Abdul Rasul and also Mishra. So, according to the framework, blended learning should be organized in 3 stages, which is learning, practice, and also assessment. And as for the data of the study, we use the score results obtained from their post-experimental report. And the score results were then analyzed and also used to identify their cognitive level. And the cognitive level I mentioned here in the study refers to the Bloom's cognitive model before revision version. And you might see that the assessment rubric here, which we use to obtain the score, contains no action verb, which was commonly used to distinguish the cognitive level in Bloom's taxonomy. So instead of using that, we use the evidence provided by the students in the post-experiment report. Now, let's see the result of the study. So, on the provided tables, you can see the summary of the identifications of the cognitive level achieved by the students. All right, and it is obvious that the cognitive level 3 appears to be the most attained category, while the low attainment is evident in cognitive level 5. All right, the reasons that we can draw on these findings is that the reasons why the cognitive level 3 appears to be most attained category is because that the most probable is because that the learning objective of these cognitive levels only requires students to experiment with the acquired knowledge about the process of dying. And the acquisitions of target knowledge can be easily ensured as the blended learning implemented features asynchronous learning, meaning that students can go back studying the lessons that they have participated, and also they can go further into the lessons they do not feel that they have understood well. And it can be done at any time, in anywhere, and as often as possible. And of course, these features allow students to build knowledge retention and better understanding. And meanwhile, the low attainment in cognitive level 5 can be perceived that the students seem to have difficulty in synthesizing and applying knowledge related to chemistry in the dyeing and also finishing processes experiment. And this finding becomes significant because this allows us to take a look whether the process of the implementations of the blended learning and the online platforms incorporated in it is sufficient or not to support students' learning to achieve this. So since the limitations of the study, we cannot really address that issue. We cannot really address or provide you with the reasons why. Because if we take a look at their post-experiment reports, the students, most of the students left it blank. I mean, they did not actually provide the evidence, you know. So we cannot really actually assess whether it's wrong or not, and we cannot really take a look at the possible reasons and where exactly the error coming from. So our suggestions for the future study, perhaps they can really examine these gaps. The findings lead us to conclude that the cognitive level student achieved in the blended learning environment could be considered quite moderate, with the cognitive level achieved by the majority of the students was C4, and also we could see that the average score was 83.12. So we can consider that the overall score was satisfactory. All right, so that's the end of our presentations, of my presentation. Thank you very much for staying with me, and we are very glad to receive your
Okay, thank you very much, Fajar, for the presentation. Fajar, are you with us?
Yes, Ibu. I'm here.
Okay, thank you, Fajar. So, anyone have a question regarding the... Alin would like to ask question?
Yeah.
Yes, please.
Okay, thank you for the presentation, Pak Fajar. I want to ask about do students doing the same activities both in offline and online learning, and what's the media used in the blended learning in your study? Thank you.
Yes, thank you very much. Would you repeat the first question again?
Do the students doing the same activities both in offline and online learning?
Online and offline learning. Oh, okay. All right, thank you very much, Ibu Alin. So yeah, the students in the final assessment, they were instructed to make or to generate a post experiment report, and with that report, we as a lecturer, we assess and also we investigate their cognitive accomplishment there. And there was no offline or in classroom assessment. Everything was done through virtual platforms. And the platforms we were incorporated into YouTube and also ML's Moodle and WhatsApp Messenger and Zoom. Yes, and their reports, their post-experimental reports, were submitted to the web that we have deliberately designed for this for the purpose of this activity. Yes.
Thank you, Fajar. How about probably Alin would like to ask regarding, sorry with the video, my internet connection has a little bit problem. So how about the project? So it is using the project for the research.
Excuse me, I don't really get what it means.
Yeah, I mean, because it is the textile chemistry physics, isn't it? So yeah. It is the knowledge only, or you integrate also the project in the student activities?
Oh yeah. So the output of the lessons was actually the students make an experiment, apply the knowledge. So the real competence is not only about cognitive, but what we assess in this study was their reports that we thought it could reflect the students' cognitive level accomplishment.
Okay, thank you, Fajar.
Okay, well.
I think it's enough for Fajar, and then we will move to the next presentation by Hima. Hima, the title is The Integration of the Ethnopedagogy in Chemistry Learning. To improve chemistry literacy and students' awareness. Please, Wahyu, to share the videos. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. I am Himaniatul Rizqol Baiti, come from Chemistry Department, Universitas Negeri Jakarta. In this conference, I want to deliver my presentation with the title Improving Student Chemical Literacy and Cultural Awareness Through Ethnopedagogy in Chemistry Education. Let's see the introduction. Based on Holman 2020, say that the main goal of high school science teaching has become scientific literacy for all students as reflected by the release of new standard and benchmark regarding content, pedagogy, and assessment, and by effort to define chemical literacy. Besides that, in 2006, the result of PISA OECD measured that student scientific literacy were the score 29% for the content, 34% for the process, and 32% for the context, confirmed that Indonesian students have low scientific literacy, which is considered to be closely related to the student incomplete understanding, where science education focuses on memorizing facts rather than developing understanding. In addition, implementation of Curriculum 2013 still requires teachers to develop more effective learning strategy that reflect Indonesian cultural norms. Based on all of problem above, ethnopedagogy can be an effective tool that connecting between the science, also the culture. This is also appropriate with Clara 2015 that say ethnopedagogy relates to the background of the ethnic groups and can help students develop the right attitudes toward national cultural values. In this study, integrating the Indonesian culture education, especially in Bangka Belitung, with the learning of electrolyte and non-electrolyte concept in chemistry. The method that used in this study is qualitative research. This study involving 31 students of grade 10 of science class consists of 5 phases. That the first one is self-identification. In this phase, students are reflected in their culture and self-identification. The second one is content integration. Students are involved in understanding culture and constructing knowledge through articles about cultural practice from Bangka. The third one is collaboration. Students complete the water heater project in groups. The fourth is dialogues. Students presented the result of their project and did some discussion with the others. The last one is reflection. Students recognize themselves and develop chemical literacy and culture awareness in collaborating with the others. Result and discussion. In this study, there are 2 results. The first one is about integration ethnopedagogy in chemistry learning. In this table, show us that there is the integration between the tradition of Bangka, such as limau purut orange using in Mandi Belimau tradition, salt stock in Takari Beach, kunci orange as an icon, and last is Kalubi as unique souvenir with the concept of chemistry. This is also the project of water heater. The result of this research indicate that the integration of ethnopedagogy and chemistry education encourage students to understand and apply the cultural knowledge to a project and in the process also developing the chemical literacy. During this project, they learn about the concept through cultural practice, which is they found interesting and meaningful. The second one is about the development of chemical literacy skill. This research based on Swartz 2015 category that saw us the result 16.13% of the students reach very good levels, 70.97% reach good level, and the rest is about 12.9% reach fair levels on the chemistry literacy test. Results show us that the student had developed chemical literacy and constructing questions, applying knowledge, and facing challenges in critical thinking skills. Students also developed general scientific ideas in identifying a solution to electrolyte and non-electrolyte content in an experiment. However, they were challenged when facing with applying scientific reasoning to the phenomenon of salt crystal in conductivity. Students had difficulty making the decision related to their everyday lives. Their critical thinking was challenged in this project because they were used to learning concept by applying that thinking to a government regulation on the prohibition of fishing using electricity. So the conclusion of this study is the integration of ethnopedagogy to create a model water heater develops student engagement, conceptual understanding, and cultural identity related to chemistry problems. Students were challenged by an experience in learning chemistry that linked chemistry concept to their local culture. Through the process, students were able to see the relevance and importance of chemistry in their daily life. The study found that ethnopedagogy develops student understanding of chemistry concept and awareness of cultural identity, chemical literacy, and also problem-solving skills. In addition, students face the challenge of shifting their identity from passive to active learners. Okay, that's all my presentation. Thank you.
Thank you so much, Hima. So Hima, Risma, and Witri, the same topic regarding the ethnochemistry, just different level for elementary schools, and then Hima in the high school. Okay, any question? Any question for Hima regarding the chemical literacy and the chemistry ethnopedagogy?
Okay, I have one, but if someone else have question, maybe they can do first because I already talk much.
That's okay, Pak Abidin. Please feel free.
Okay, if nobody asking the question, so it's fine then. Okay, Hima, right?
Yes.
Yes, yeah, Hima. When you did
Yes,
this
sir.
ethnopedagogy, what teaching strategy that you implemented in the class? And then in ethnopedagogy, in ethnopedagogy in general, is there any specific teaching approach that suitable to be applied in such chemistry teaching? Yeah, that's the question. Thank you.
Thank you for nice questions, sir. What is the strategy, right, for the learning method?
Yeah.
Yeah. Okay, for the ethnopedagogy itself, before we doing a research, we must identify the type of the student itself. So in the first step, we had like questionnaire that exploring what is the type of student strategy. What's that ya? Seperti gaya belajar gitu, Pak. Ya, jadi kayak gaya belajar studentnya. Nah, after we get collecting the data, after that we use actually the contextual and also the active learning for the method. So we use like the presentation and then some discussion also. Actually, the most of the learning is engage the student to be active and exploring the material within their daily life. Is it enough, sir?
Okay. What level of education for this study?
High school.
High school, yeah.
Yeah.
Okay. So, do they always did the collaborative based work or individual?
Yeah, collaborative. Yeah, because we will also membagi creating a group first for each student so that they can doing discussion and then sharing with the partner to do the project like that. Sorry.
Okay, so is it possible to suggest that for secondary education level, if we would like to apply the ethnopedagogy, it is recommended to do the collaborative work, collaborative strategy instead of individual one. Because do you think that's the case to be suggested?
Yeah, actually, this study conducted in many level, not only in high school but only in secondary and elementary. So within our research, we can see that this strategy also can appropriate with collaborative method.
Okay, I think that's all. Thank you.
Yeah, thank you, sir.
Thank you, Pak Abi. The research funding is funded by the Ministry of the Higher Education before it's become a culture and education, and then it is multi-years research. So we as a research group moving in different islands in Indonesia. So the research that we presented here is from Bangka. And in Bangka, we are working for elementary, junior high school, and secondary school. And the teaching model is developed by ourselves. So if you're asking about how the teaching models is developed by ourselves, and then our research group, and the basic principle is the culturally responsive teaching by Henderson, and then the other principle of constructivism. So the way develop each step is based on different kind of theoretical background. So hopefully later on, if you can read our papers, it will be different kind of result that we have been presented in the publication. Thank you, Pak Habibin.
Yeah, thank you, Bu Yuli, for the explanation. I think I will read some of your paper regarding this issue because that's very interesting. Maybe I can do more the relevant of this idea.
Yeah, because
thank you.
If you see the rich culture of Indonesia, we just cannot finish it up, because once even you only visited Bangka, we only do the small things of the Bangka's cultures. It's really, really small compared to the whole part of the Bangka Belitung.
Yeah, but I'm actually interested to start with my own culture from in Sulawesi, right?
Oh, that's good.
Yeah.
That's good. Very nice.
Yeah.
Okay, so we have the next presenter. Thank you, Hima and Pak Abidin, for asking the question. And then hopefully you're still awake because...
Yuli, sorry.
Suara ya?
Yes, yes. I think there is one more question from Elda in the chat.
Okay, okay. Elda,
do we have another time? Yeah.
I want to ask, this is the project of ethnopedagogy. Are the instrument used? Oh, okay. So, yeah, we have the scientific literation. Witri, can you show us the scientific literacy part? What we call it? The rubric.
Test or what?
Yeah, the scientific. Witri is still there?
Yeah, I still here.
So if Witri not yet get on the computer, so yes, Elda, we have the chemistry literacy by Swartz and also the scientific literacy. So we have the rubric and we develop the scientific literacy test based on the criteria, based on the rubric. And then for the, since it is qualitative, the test is only a part of the data collection. So we use the interview, we use the reflective journal, we use the observation. So not only the test only giving us the ideas, how the students get the understanding of the scientific or science concept or the chemistry concept in the level of literacy. So that's the one that we presented here is only a small part of the data, because we have different level of the big data that we have in the research. Okay, that's The thing that Alin shared, it is a chemical literacy rubric developed by Swartz. So he or she, I forgot. He developed the different assessment criteria and the different level of the performance from absent into mastering. So hopefully it is clear, Elda. Thank you. Thank you, Alin. And then so for the next presentation is it is Hima, and then it is by Halimatus Sa'dia.
Yes.
The title is Transformational Barriers Adapting the Halimatus Sa'dia. The transformational barriers in adapting the online learning for chemistry during the COVID-19 pandemic. Please do share the video, Wahyu. Thank you. Please do the relaxation because probably you're getting tired after this couple hours. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi ladies and gentlemen. Let me introduce myself. I am Halimatus Sa'dia and I am PhD student of Educational Technology of State University of Jakarta. In this occasion, and due to outbreak of COVID-19, I would like to deliver my online presentation to SMIC 2020 International Conference. My paper title, Transformational Barrier in Adapting the Online Learning for Chemistry During COVID-19 Pandemic. Transformational barrier in adapting the online learning for chemistry during COVID-19 pandemic. Introduction. The end of December 2019 was the beginning of worldwide catastrophe. Beginning in 2020, COVID-19 has devastated all sectors ranging from economic, social, cultural, environmental, community order, and education sectors. Education system has changed drastically. The Ministry of Education issued a circular number 4 of 2020 concerning home learning policies, which include number 1, true online learning or distant learning providing meaningful learning experience. Number 2, learning is focused on life skill education, including pandemic COVID-19. Number 3, learning activities and assignment from home can vary between students, including considering the ease of access learning facilities at home. Number 4, evidence or productivity of learning from home given qualitative feedback and useful for teachers. Challenge of learning at home with an online mechanism is the provision of access to supporting facilities and the number of tasks assigned by the teacher to students for purposing curriculum completion. This is a new challenge for school at elementary, junior high, and high school levels. Various attempts were made by the central government, local government, and school level in order to find the best formula in learning. Effort to obtain data from the community through surveys, field observation, direct interview with students, teachers, parents, school committee, and students, and the community policy analysis. Methods. Methodology used in this study is a systematic of literature analysis. The systematic literature review was conducted in 5 stages: formulating the research problem, identifying relevant work, assessing the quality of studies, summarizing the evidence, and interpreting the finding. Result and discussion. Based on data from the Ministry of Education and Culture, which had conducted a quick survey during the pandemic, the following data were obtained. 51.6% of teachers pursue curriculum completeness, while 48.4% do not pursue curriculum completeness. This means that most teachers do not prioritize completeness of student knowledge competencies according to the demand of the curriculum that should be. If this pandemic continues beyond one semester, it will be a bigger problem for the community, especially education. They need policies and strategies, new innovation, so as to produce a new model, strategy, and learning model. Encourage education toward the digitalization of the education system, and change the role on interaction of the teacher-student in learning. Chemistry is a science subject that experiences problems in this pandemic. Where learning is carried out remotely, students complain that it's difficult to understand chemistry, especially on material that contain algorithmic calculation. Some of the steps faced by chemistry teachers in learning in the COVID-19 era. Number 1, using the concept of problem-based learning in a flipped classroom learning environment. Number 2, using collaborative system, small group in online and offline learning. Number 3, preparing videos learning to assist students in repeat and practicing material that is considered difficult. And 4, the teacher prepare himself in face-to-face process directly with students, which still adhering to COVID-19 epidemic protocol. And conclusion, learning in this pandemic period, many benefit to students, teachers, parents, school, communities, and government. Students become more skilled in managing their time in independent learning process. Students are trying to find learning results that fit their needs. Students practice sorting of essential material that must be understood and need to be discussed in more depth with teacher or sufficiently understood through the safe learning process. And other benefit, this pandemic situation made us all become more concerned about the importance of healthy lifestyle and maintaining health. I hope my presentation can add to our knowledge about transformational barrier in adapting the online learning for chemistry during COVID-19 pandemic. Stay at home, stay healthy. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih. Thank you very much, Bu Halimah. Anyone having a question? Probably we face, probably we face the similar situation regarding the COVID-19. So anyone asking question?
Yeah, I want to ask.
Okay, good, very good. Witri, please do the question. Pak Bu Halimah, Witri asking question.
Yeah, thank you for the question. I would like to ask, I found that you write on your presentation is using offline learning in collaboration. Can you explain the purpose of it? Because it's still pandemic, and then you write on your presentation that we can use offline learning in collaboration. Can you get it?
Yeah. I'm so sorry because I can speak English very well. I will explain Indonesian. Please the committee to have to become translator. Untuk menjelaskan materi kimia ya secara online dan offline itu dilakukan, kita strateginya menggunakan flip classroom ya. Jadi sebelum kita masuk ke kelas, kita memberikan materi-materi, meminta siswa untuk membaca link atau memberikan materi-materi tentang konsep, tentang fakta-fakta yang harus mereka baca sebelumnya. Kemudian pada saat bertemu di tatap maya, kita membahas hal-hal yang penting tentang konsep-konsep yang siswa belum ketahui. Kemudian untuk materi yang lebih sulit lagi seperti materi untuk algoritmik, untuk perhitungan, misalnya seperti materi pada termokimia, ya termokimia itu menjadi suatu problem buat siswa ketika kita belajarnya dari online saja. Akhirnya kita memberikan waktu tatap muka, namun tetap menggunakan standar protokol penanggulangan COVID-19, yaitu dengan siswa digilir, jadi maksimal itu dalam satu kelompok 3, namun demikian satu kali pertemuan itu kita dibatasi hanya 10 siswa. Tentu saja dengan meja dan sebagainya itu kita batasi dengan plastik yang ada batas antara siswa dengan plastik yang ada batas. Nah, itu yang dilakukan oleh sekolah ya. Kebetulan saya melakukannya itu di SMA di Bekasi, di salah satu SMA di Bekasi. Jadi kita melaksanakan pembelajaran untuk mata pelajaran sains dilakukan dengan cara seperti itu. Karena memang sebelumnya kita sudah melakukan penelitian terhadap 3 level siswa, jadi mulai kelas 1, kelas 2, kelas 3. Ternyata problemanya itu hampir sama, yaitu mereka mengalami kendala terhadap mata pelajaran yang sains, terutama matematika, fisika, dan kimia. Nah, mungkin seperti itu. Akhirnya kita mengambil langkah pembelajarannya dengan flip classroom dan tentu saja dengan kolaboratif. Nah, untuk tugas-tugas yang tidak perlu kita langsung tatap muka, kita tetap melaksanakannya dengan kolaboratif. Siswa-siswa mengirimkan video, kemudian dia mempresentasikan lewat share screen dari Zoom meeting. Mungkin seperti itu, Bu Yuli.
Ya, terima kasih Bu Halimah. Interesting ya inisiatif dan kreatif ya, karena memang terbatas ya online juga. Saya mohon maaf ya, video nih ternyata jadi unstable. Bill, I would like to explain regarding, because it is in bahasa. So the question is, they try to do during the COVID-19 we do online, but since some of the subject like chemistry, some of the difficult subject to be conducted in online. So Bu Halimah is trying to make it like blended with the flip classroom. So in the offline, there is only 10 students. She gave us the example of 10 students. So they are working together, but with the working distance. So to manage the collaborative work. So the situation in Indonesia is not really good for the COVID-19. So the schools still locked down, and then we just mostly do all the activities with online, and we face the challenge of the practicum and the scientific observation through the online learning. So it is trying to find out the innovative ways to engage the students, not only fully online, but also combine the blended, combine the offline and online. So that's the discussion, Bill.
Right, thank you very much. I could perhaps add something about the situation in Melbourne.
Yes, please.
If I may. It's not really a question, just to say that in Melbourne we're on stage 4 lockdown and schools have effectively closed, all schools. So for the grandchildren, the online material they're getting, for 2 of them I think it's good, and for the other one it hasn't been too good from his school.
Yeah.
So just as general information, and so nothing's perfect.
Yeah, right. Yeah. So right now the school is still locked down in Melbourne.
Yeah. Oh. Yes, so all the schools, we're in stage 4 now for 6 weeks.
Okay, I think Australia already getting back normal.
No. Well, Melbourne is in Victoria, and Victoria is different to the other states.
Okay. Yeah. Okay. Wow. How about us? It will be getting very challenging.
Yeah. Right. Thank you.
Thank you, Bill. Thank you, Bu Halima. Thank you, Witri. Thank you, Bill, to give a response. And then for the next presentation, we have Christia Nurbaiti. The title is Development of the Electronic Module. We call it E-Module of carbohydrate using the professional flip PDF application in organic chemistry course. Please, Wahyu, share the videos of the Chris. Thank you.
Is Ibu Christina here?
Assalamualaikum warahmatullahi wabarakatuh. Hello, ladies and gentlemen. My name is Christina Nurbaiti. I am a magister student at Jakarta United States University. In this opportunity, I would like to present my paper, and the title is Development of Electronic Module Carbohydrate.
Ayo, pause dulu. Orangnya ada nggak?
Is Christina here? I think I saw
yes,
her.
Yuli.
I think I saw Christina on the list before. Is he left? Is Christina?
Pause dulu.
Oh, Christina is not here, not yet, because I saw her on my list. Rifai or Indah? Is Christina join us with us, isn't it?
Can we move to other presentation if
we are really sorry, I think, because after the after the break we still have the 3 presenters, so I think we just pass through the break if you don't mind, everyone, because it's just 3 presenters left if the Christina is not with us right now. Okay, so Indah, please, are you there?
Yes.
Okay, good. Okay, Wahyu, please do the share presentation of Indah first.
Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, today I'll present our study about the impact of Industrial Revolution 4.0 on chemistry learning in Indonesia. Industrial Revolution 4.0, also known as Industry 4.0, is currently becoming technological trend in the smart manufacturing process in the world. It is indicated by the use of advanced technologies such as autonomous robot, 2D and 3D simulation, system integration, Internet of Things, artificial intelligence, cybersecurity, cloud-based IT platform, additive manufacturing, augmented reality, and big data. General economic, social, and political changes accompanied by information and communication technology which increasingly develop in initiating Industry 4.0. In fact, some of these technologies are not only used by the manufacturing industry, but are also used in everyday human activities. For example, e-commerce platforms use big data cloud-based IT platforms to display real-time data stock and product prices, and even the payment process become easier with e-money. Some of them use augmented reality technology as an application to assist customer in determining the choice of product to be purchased. Industry 4.0 also affected to many kinds of fields of life, such as health, tourism, communication, and even education. So, the job market today not only requires workers who have knowledge, but also requires workers who literate technologies used in Industry 4.0. Therefore, universities as institutions for prospective workers must link and match with job market needed. So, universities must make efforts in order to equip their graduates to be a part of society that can survive in new era. This study discussed how the condition of higher education in Indonesia, especially on chemistry education program. This is an analytical study with concept analysis design approach. This study examines a variety of literature related to the Industry 4.0, the use of augmented reality and virtual reality as a learning media, as well as the learning condition of basic chemistry courses at several universities in Indonesia, to find out whether the learning process has led to the era of the Industry 4.0 or not. In fact, teaching and learning activities in basic chemistry in several universities in Indonesia have not shown the existence of innovation that equips students to face the era of the Industry 4.0. This can be seen from the form of semester learning plans, or RPS, of basic chemistry courses that they used. Findings on Table 1 shows that the chemical content being taught is not yet applicable to technology, and the form of the learning plans does not indicate that use of instructional media that use the latest technology used in Industry 4.0. This situation shows that there is a need for curriculum innovation, especially in basic chemistry courses. This innovation needs to be done to improve the quality of chemistry learning so that prospective chemistry teachers and prospective chemists gain learning experience that provides the knowledge and skill needed to face the era of the Industry 4.0. Universities need to improve their educational approaches and methods to make future learning more customized, hyper-intelligent, portable, worldwide, and virtual. Latest technologies such as augmented reality and virtual reality and other technological advances need to be introduced so students can learn about these technologies. AR and VR can be used in chemistry learning. The characteristics of chemistry learning, such as contains abstract topics that require visualization and perceptual spatial orientation, and then require multiple representation, namely macroscopic, submicroscopic, and symbolic, and then in chemistry learning also doing laboratory activities. So, AR and VR has the potential to effect a transformation in chemistry learning process. It can make positive impact to various learning outcomes, such as conceptual understanding, submicroscopic representation ability, spatial ability, problem-solving ability, motivation, interest, engagement, attitudes toward lab safety, team building, communication, self-efficacy, and also technology literacy. Furthermore, universities must improve the internet network to make it easier to students to access the internet both in learning in classroom and when studying independently outside the classroom. Innovation must also be made in the learning process. The learning process must facilitate the student to practice problem-solving skill. To face the era of the Industry 4.0, students must have problem-solving skill, so that one day they can solve problems in everyday life. Furthermore, students must also have creative thinking skills. Creative thinking skills are needed especially in the era of the Industry 4.0. This skill will make students able to create new things that may be the source of their future life. They will be able to create objects that currently do not yet exist. So, we can conclude that higher education in Indonesia must innovate in its learning, especially for chemistry programs and chemistry education programs in basic chemistry courses. Innovation that need to be made are in terms of chemical contents that must be linked to the latest technology. The learning process must provide problem-solving skills and foster creative thinking skills. The learning media used must use the latest technology, such as augmented reality and virtual reality. To support this, universities must improve the internet network to make it easier for students to access the internet both in learning in the classroom and when learning independently outside the classroom. Okay, this is the end of my presentation. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you very much, Bu Indah. Anyone would like to asking question? It's similar study with Bu Halimatu Sa'dia as well regarding the COVID-19, and then it is about the, I think it will, since they are PhD students, PhD student ya Bu Indah?
Yes.
Doctor students, yeah. Since they are PhD student, it is a part of big studies regarding the chemistry learning during the COVID-19. Anyone asking question for Bu Indah regarding the chemistry learning in COVID-19?
Yeah, maybe I have one if it's
yes.
Nobody asks.
Pak Habibin, we are a silent. Okay, please do.
Okay, maybe the question is a bit general regarding the online learning, or yeah, particularly in during COVID pandemic. One of the issue in online learning, like some teacher, they just move the offline lecturing to online lecturing. So maybe the Halima, as a researcher in this area, have a suggestion to cope with this issue. Okay, that's the question.
Please, Bu Indah.
Yeah, can I answer in bahasa?
Yes, please.
Yes.
Ya, memang begitu Pak. Jadi selama pandemi ini, penelitian sebelumnya juga saya ke beberapa universitas dan juga ke beberapa sekolah SMA di Jawa Barat dan Banten, memang hasilnya seperti itu. Ketika pandemi COVID-19 ini, pembelajaran kan online. Nah, sebagian besar siswa itu tidak menyukai pembelajaran online karena mereka berpendapat guru itu hanya mengajar sekilas saja gitu, hanya poin-poin penting yang guru sampaikan, entah itu via Zoom meeting atau pakai Google Classroom, tapi tugasnya itu sangat banyak gitu. Dan mereka merasa kesulitan untuk bertanya, seperti kalau di kelas kan mereka bisa diulangi nggak Bu gitu, tolong dijelaskan ulang. Kalau online kan mereka bisa nggak bisa, ya sudah telan saja, apalagi dengan mereka ada di rumah, mungkin dalam tanda kutip misal yang orang tuanya abai gitu dengan pembelajaran mereka, ketika mereka ingin bertanya ke siapa itu tidak bisa gitu, tidak ada. Makanya ini jadi tantangan berat untuk kita, dan itu yang menjadi mendasari salah satu penelitian saya nanti, dan terutama mereka kesulitan pada saat praktikum. Beberapa guru ada yang mau bersusah payah mencoba mencari kira-kira alat dan bahan apa gitu yang bisa mereka temukan atau yang bisa siswa temukan di sekitar rumah gitu. Jadi praktikum tetap berjalan, nanti siswa praktikum lalu divideokan dan dikirim ke guru. Namun beberapa guru ada yang tidak mau serepot itu gitu. Jadi ya sudah, praktikum nggak ada aja. Ada yang kasih video nih, kalian tonton saja gitu. Jadi mereka kurang tidak terlatih gitu keterampilan hands-on-nya jadinya. Bagaimana Pak?
Yeah, thanks for the answer. Yeah.
Yeah, I think Bu Indah, ini kan memang semua ya, dan thank you so much for getting the data that we used to heard about the overloaded students assignments, and then how the teachers difficult in engage student during the COVID-19, and then mostly because the IT competencies and some of the teacher only use the platform that they can access, and then they can use it. So your research will be contributes to engage the students in chemistry learning during the COVID-19.
Amin.
Okay. Yes, Amin. Thank you so much, everyone. I also didn't find the Budia in the presentation, in the participant here. So probably Elda, can you hear us? Elda?
Yes.
Okay.
Yes.
So we will move to your presentation. Everyone, Elda is our last presenter. And then if you know that the chemistry education room is the longest, probably the long ya, Bu Ella ya?
Yes, everyone is here, is just finished, and I'm the one.
So it's only the room is still available. So for tomorrow, you can join.
That's because Bu Yuli team.
So if you would like to, for tomorrow, if you would like to join different room, you can move to room 1, room 2, and then until room 10. But be aware that different room is different, what we call it, discipline, the study, this
Just
discipline.
click the link.
So,
just click the link.
Yeah, just click the link. So it will be chemistry, only chemistry education, science education, math education.
Yep.
So please do if you would like to do for tomorrow. So Elda, we would like to share your presentation as the final presentation before we end the session. Wahyu, please do share the Elda presentation now. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning. I'm glad to see you all at SMIC 2020. Let me introduce myself to you. My name's Elda Frediana Ratikatika, and I'm from 11 Maret University. In this presentation, I would like to present my paper, and the title is Pre-Service Teachers' Perception and Knowledge in Integrating STEAM in Chemistry Learning. Okay, first I would like to explain about the introduction of this paper. The introduction of this paper would explain 21st century learning. In the 21st century era, learning must be able to adjust student competency such as creativity, collaboration, critical thinking, media literacy, and entrepreneurship. This competency would help students for facing the challenge of their real and future life. In Indonesia, research conducted by PISA showed that Indonesian students have low-level interest in learning science. This phenomena also happened in chemistry subject. Many students feel the chemistry subject is not relevant with their life and is not interesting. Because of this reason, STEAM was designed to promote student understanding and interest about the science. STEAM is based on STEM education, which is connected with art, helping students have more success and understanding the hard science, technology, engineering, and mathematics. Integrating arts in science interprets the material based on personal experience to increase the meaning and enjoyment of learning. STEM also have an essential role in developing 21st century skill. Parallel with university vision becoming the top development center for science, knowledge, and arts, STEAM is one of the suggested studies. Chemistry is one important subject which studied the matter, energy, and the interaction between them. Contextual chemistry also needed to be taught to solve student problems using their chemistry knowledge. Unfortunately, STEAM is not well known among in-service teacher and pre-service teacher. They feel difficult to apply STEAM in class because of insufficient time and lack of educational materials. For this reason, pre-service teacher training program integrated with STEAM in chemistry education are needed. Second, I would like to explain about the methodology of this research. We use mixed methods approach to explore the perception and knowledge of pre-service teachers towards STEAM. Quantitative approach consists of single question survey. Survey uses a semi-open questionnaire. Survey involves 28 pre-service teachers studying the third-year student at the Department of Chemistry Education in a public university in Surakarta. Qualitative approach was an interview. A fully structured interview was taken after the service teachers answered questions on survey. The interview was participated by a pre-service teacher who knows better than others. In this initial study of high interest in STEAM education, we are interested how perception and knowledge of pre-service teachers about STEAM. In this context, there are two main focus areas, pre-service teacher perception and pre-service teacher knowledge. The results of questionnaire analysis in the future showed that in aspect and initial understanding of STEAM, only 36% of the participants who is understanding STEAM in full definition. 64% of the participants would feel confused of what STEAM is, an approach or learning model. All of the participants said that STEAM could be applied in chemistry. Among 33% of participants said that STEAM could be applied in all chemistry topics. Parallel with the results of aspect initial understanding of STEAM, it's proper that they are hesitant to link what topic is suitable for STEAM. In the aspect of development of STEAM-based learning tool, only 14% of the participants who successfully designed STEAM-based learning tools. 86% found it challenging to design. No participant was successfully linked STEAM with learning models and allocate the right time for STEAM. All the participants mentioned that STEAM was contributed in chemistry learning. They said that STEAM could be able to visualize abstract chemical concepts. In the aspect of the challenge of implementing STEAM, 80% of participants said they applied in chemistry class is challenge. Not all teachers master arts, and it makes own problem of implement STEAM in chemistry. In the aspect of STEAM implementation, the result was appropriate with the aspect of STEM implementation that only get 7% participants who explain the stage of STEM implementation in learning. 93% of the participants difficult to apply STEAM in classroom. Based on these results, 28 participants just had known in general terms. Nevertheless, pre-service teacher had a favorable opinion on STEAM education. This result was obtained from 100% of participants who responded to STEAM made a significant contribution of chemistry learning. After survey, 8 pre-service teachers were selected with the right answer when they were surveyed. Some of the questions asked to explore how in-depth knowledge and perception are, and for members to check their survey answer. Based on the response, We can examine pre-service teacher perception knowledge based on the response following this item. First, STEAM education is needed in chemistry learning. Knowledge about STEAM is still in general terms. And third, many challenges are faced with implementing STEAM. Almost all pre-service teachers found it challenging to choose a chemistry topic that can be integrated with STEAM. They cannot imagine how implementing STEAM in class. The last, we can conclude that pre-service teacher presentation, the pre-service teacher perception in the low level category, and their knowledge is still in general terms. We also found the challenge while implementing STEAM, such as the difficulty of time management, insufficient instructional materials, long duration of some activities, and not all teachers are creative. Master of Arts are need to be explored. Given the pre-service teacher as a future principal agent of policy implementation, the current pre-service teacher training program based on STEAM are required. Okay, this is about my presentation. Thanks for attention and good morning.
So thank you, Elda. So it's good afternoon right now. Just kidding. Okay, any question for Elda? Elda research on the survey regarding the how to implement it STEM in the chemistry learning. Adri, any question? Andri? Hima, Risma, Witri. After this, we need to have look your video because we would like to take a picture.
That's important.
Okay, Bu Risma, any question regarding Elda presentation? The survey on the STEM education in chemistry learning. Pak Ridwan, are you there? On only the pictures.
Yeah, Bu.
Okay, good. Okay.
I think there is no question.
No, thanks.
Elda, may I?
Oh, Witri.
Witri, okay, Witri, silakan.
The last.
Yeah, thank you for the occasion. Actually, I'm very interested with your research. Is there any other superficial or outside from your research? Is there just survey or you give some suggestion? Because I have do about STEAM with Aline and then maybe you give some suggestion for us to do STEAM learning in our class. Thank you. Can you get my question?
Okay. I'm give a survey with the participants, and then I'm choose the 8 participants who know better than others. And the survey is based on literature journal or review literature and from the maybe from book.
So, what do you think, Elda, from your survey, Witri asking, what is should STEM implemented? For example, should STEM implemented in the chemistry learning, or what is the interesting part from your study regarding integrated STEM in chemistry?
In my research, all the participants have.
Participant is the university students, right?
Yes, the participant of the university student, they have a known about the STEAM. So, if I survey about the STEAM, they cannot imagine how STEAM is and how design STEAM in classroom. They feel confused what STEAM is, learning model or an approach. and on approach, they feel very confused, and they found challenge to apply STEM in chemistry classroom.
Okay, yeah, it's our challenge since in Indonesia we learn different subject, not as integrated of STEM STEM. We just chemistry, bio, and so on. So it's the challenging. Okay, very good, Elda. Thank you. Are you Bu Nurba students?
Yes.
We have met before.
Yes, in
Solo.
the program.
Okay, good. Thank you, Elda, to join us today. Everyone, it is the end of our program. Could you please open up your video if it is okay? Because we would like to taking a picture of the
Wahyu, open your video.
presenter.
Turn on your video, please.
Thank you, Wahyu, Nisa, Dian, Pak Ridwan,
Halimatus.
Dian, are you there? Febri? Hima? Okay, very good. Yes, Nisa. Hima, not yet there. Bu Dewi, are you okay to open up the video?
Rifai.
Okay, good. Rifai? Okay, are you not in the car? I used to talk with Rifai in the car. Okay, Hima? Not yet. Dewi, Bu Dewi? Okay, good. Pak Hafidin already moved to another room.
Okay, I will take the picture. Are you ready all?
Okay, good. Hima, not yet, yeah? That's fine. Oh, Bu Halima probably still use the... Okay, Bu Andri already there. Hima, Bu Dewi. Bu Dewi is join the... What you call it? The PPG examination. Bu Halima, you would like to join us? Hima. Bu Dewi. Okay, probably we just wait for Bu Halima. Because I think many participants in this room, ya Bu Ella, ya. Because the rest only have 5 or 6.
Yeah, 21.
Yeah. 21. So
21. Wah, Pak Hamidin has already moved to another angle.
Oh, I know this room. Okay.
Ready?
Bu Halima. Bu Halima still. Okay, good. Okay, good, Bu. Thank you. Bawahnya daster ya? Legging. Oke. Oke, Bu Halima ready ya?
Yes.
Satu, one. Bill, we would like to take a picture. Okay, thank you, Bill. Okay, 1, 2, 3. One more. Probably we just use our symbol ya lah. We used to say K.
Yeah.
C is chemistry.
C for chemistry. Yeah.
Okay.
Yes.
Okay,
everyone.
2, 3. I cannot. One more. 1, 2. Oh my goodness. 1, 2, 3. Okay, thank you so much, everyone. See you tomorrow. Stay healthy and safe because we are in pandemic situation and seems to be getting worse. Thank you so much. Good afternoon. Thank you, Bu Ella. Thank you, Wahyu, to assist me. And then I will close this room and see you tomorrow. Thank you. Bye. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Bill, everyone. Bye-bye.
Thank you.